So good evening, everyone, dear ambassadors, dear friends of the Institute. Welcome to tonight's event, Space for Net Zero. I'm Nicola Locatelli, the director of the Italian Cultural Institute. Tonight, we are very happy to have two special guests with us, Simonetta di Pippo and Köberl, who will talk about how can space-based projects and technologies contribute to the achievement of the 2030 Agenda for Sustainable Development. Before introducing our two guests, I would just say a few words about the event. First of all, I would like to say that this is the first of a series of events that we will hold in English, as they are aimed for a larger audience here in Vienna and beyond, who doesn't necessarily speak Italian or German, but could be interested in these relevant topics for our contemporary world. This event is also recorded and will hopefully make it on our Vimeo channel, so that even those who didn't make it tonight can watch it in the future. Just a couple of words about tonight's event, and then we will introduce our two guests. First of all, I would like to say the occasion of this event is the publication of this book by Simonetta di Pippo, which is called Space Economy, the New Frontier for Development, in which she talks about the opportunities provided by space economy in creating benefits for humanity and tackling climate change. As you may know, satellites are critical to monitoring greenhouse gas emissions and different climate change indicators. And in fact, according to the white paper Global Future Council on Space, Space for Net Zero of the World Economic Forum, more than 50% of essential climate variables are measurable only from space. However, gaps remain in modeling, mitigation, and coordination. And while hundreds of institutions conduct research into relevant climate change processes, an Earth Operations Center has yet to be established that leverages space data and expertise to conduct multidisciplinary science and engineering research, inform decision-making, and coordinate net zero efforts. So this is what we will talk about tonight. I will shortly introduce our two guests and then hand over. Simonetta di Pippo is Professor of Practice of Space Economy at the SDA Bocconi School of Management in Milan. Prior to joining SDA, she served as Director of the United Nations Office for Outer Space Affairs, Director of Human Spaceflight at the European Space Agency, Director of Observation of the Universe at the Italian Space Agency, and led the European Space Policy Observatory. Throughout her career, she has been active in bridging the gender gap in STEM and the space sector. In 2009, she co-founded Women in Aerospace Europe, and in 2017, she became a UN International Gender Champion. In 2008, the International Astronomical Union named asteroid 21887 Di Pippo in honor of her contribution to space activities. And Köberl is Professor of Impact Research and Planetary Geology at the University of Vienna. He is a member of the Austrian Academy of Sciences, books editor for the Geological Society of America, and co-editor of the journals Geochimica et Cosmochimica Acta and Meteoritics and Planetary Science. He is a recipient of the Barringer Medal of the Meteoritical Society, its highest award for research related to impact cratering studies, the Meteoritical Society's Service Award, and he has received the Austrian Cross of Honor for Science and Culture First Class. From June 2010 to May 2020, he was the Director General of the Natural History Museum in Vienna, and in 2006, the asteroid 15963 was named Köberl after him. So before handing over to our guests, I think the Italian ambassador Stefano Beltrame would like to address a short speech. Thank you very much.
Ich wollte nur etwas kurz auf Italienisch sagen. Noi qua siamo all'Ambasciata d'Italia, Istituto di Cultura Italiano, grazie di essere con noi. Due parole per chi si dovesse chiedere ma come mai gli italiani parlano di spazio. Beh, l'Italia è il quinto paese al mondo ad aver messo in orbita un satellite artificiale col programma San Marco nel 64, 7 anni dopo lo Sputnik. Quindi da allora in poi... Quindi da allora in poi l'Italia ha sempre avuto un ruolo nell'Europa continentale, diciamo così, di avanguardia nella ricerca spaziale. Proprio oggi il Vice Ministro degli Esteri diceva che ci sono in Italia 200 aziende che lavorano nel settore aerospaziale per un giro d'affari di 2 miliardi di euro. So, to whom might wonder why Italy is talking about space, I just wanted to remember that Italy has been the 5th country in the world to put in orbit an artificial satellite. That was 7 years after Sputnik, the Russians started. And still today, Italy is in continental Europe one of the leading countries in the space economy with something like 200 companies and 2 billion euros turnover. I stop here and I give the floor to Simona.
Asteroid, you first.
Yeah. Common asteroids, I hope they never collide. You know?
Well, you never know.
Well, I guess since I'm the moderator, I'll start by mentioning that we have known each other for some time through activities back at the Natural History Museum, but also activities at UNOSA but I don't want to dwell in the past. We should kind of talk about
the future,
the present and the future. And the topic of what space can do for people back on Earth is, of course, a very important one, not only in terms of science and advances of science, maybe we'll talk about some interaction about that later, but also, of course, as you phrase it in your book, it is important for the economy of the world, and the economy is what keeps things going. So I think for starters, everybody will be interested in hearing, I would say, a short version of your book.
Oh, right. How many hours do you have? Joking.
The abstract.
I was joking, clearly.
And an overview, what kind of you see as the most important items and topics in terms of what space can do for us in a way, and also the economic implications. So, and after that, we'll have a little bit of a discussion here, and then we'll involve anybody who would like to ask questions. So, Simonetta, please.
Thank you. And thank you very much to all of you for being here with us. Well, I have to say, first of all, that I left Vienna now as a little bit less than 1 year, after 8 years as the director of the Office for Outer Space Affairs. So I've been living here in Vienna. And I have to say a little bit today, when arriving from the airport, I had, that feeling that, oh, okay, yeah, was a great place. Not because Milan is not, but, where I'm currently. So the book came out, let's say, the consideration I made in writing the book is that there are a lot of people talking about space economy and what it means and what it implies and why space is so important for what we do in our day-to-day life. And but looking around, on a global scale, I didn't find any, let's say, even if short, let's say, compendium of what space can really do for us. And so I thought that it was the right time to also try to increase awareness of the importance of space for us, and not only for us in developed countries, but also for developing and emerging countries. And by the way, this was the main goal or at least for the capacity building part of my job when I was under my, let's say, my responsibility as director of the Office for Outer Space Affairs. And in particular, it's very rare that you find in books of this kind, when talking about space economy, you rarely see something related to the 2030 Agenda for Sustainable Development and the 17 Sustainable Development Goals, even if there is a certain understanding, at least in academy and in other areas, about the importance of the 17 Sustainable Development Goals. It's not so evident, the link between space and how policy and decision makers can really benefit from space. By the way, when I was director at the UN, we did a study. We performed the study together with the European Union Space Agency. It's called EUSPA. At that time it was called GSA, but then it evolved in EUSPA, which is reporting to European Commission, based in Prague. And they put together some interesting technical data on Earth observation. That is the European constellation called Copernicus, and the European GNSS system, which is Galileo. GNSS means Global Navigation Satellite System, which means these constellations of satellites which support the possibility for us to, is the equivalent of GPS and the American GPS, and allows us to geolocate, let's say, various points and support navigation. So we put together these two systems, and we analyzed not only the 17 Sustainable Development Goals, but in particular the 169 targets which are underpinning the 17 goals. And in a very conservative manner, we found that more than 40% of these targets can only be achieved if we use space. Otherwise, it would not be possible. And if you add high-resolution images and also satellite telecommunication, which was missing in the picture, well, you reach more or less 50%, which means that each country in the world cannot reach the goals that we are supposed to reach by 2030 without space. And as was mentioned before, if we look at climate change and all the impacts that we have to deal with today and in the future, WMO, so the World Meteorological Organization, a few years ago established 54 essential climate variables, which are the variables that you have to follow in order to understand or try to understand what's going on. Because believe me, it's not so clear what's going on, at least not 100%. And more than half of these variables can only be monitored in a precise manner, as it was mentioned, from space. And in addition to that, if you combine the two, so the 17 Sustainable Development Goals plus the 54 essential climate variables, and considering that a lot of SDGs are related in a way, are linked to the environment and to climate, well, you understand how is the role that space can play, not only for the improvement of the quality of our lives, but also in a way how space can be really supportive to try to tackle this challenge, which is climate change. Now, the point is that there is also another side of it, and the side is that if we look at the last report of the IPCC, we find that, for example, agriculture is impacting more or less 25% on the emission of greenhouse gases, 25%. Aviation is 7%, and if I remember well, construction is more or less 40%. 40%. So, which means, what it means? It means that if with space technologies, with space research applications, we could reduce, for example, the impact of agriculture on the emissions, well, it's another contribution to the process of trying to tackle the climate crisis that we are facing. You probably have read also that in the last reports, while at COP21 in Paris in 2015, the limit was established in 1.5 degrees Celsius, we are currently at 1.3. And this was not supposed to be the case today, which means that the temperature is rising at a higher speed, and the impacts are not necessarily predictable 100%. Also because the system Earth is reacting to what is happening in terms of global warming, etc., with a certain, is slow, the answer of the planet to what is happening. So even if today we could switch off all the emissions and go back to the levels, the pre-industrial levels, well, still the impact will be visible for a long period of time. So with space, we can do two things, as I said, at least for space for net zero. Net zero is the balance between emission and absorption. And the sooner we reach net zero, the better it is for the planet. And clearly, you can imagine scientists all over the world are trying to find solutions, in particular for absorbing these greenhouse gases, which is not as easy as it may sound, by the way. So the point is, we should also try to reduce the emissions themselves, for example, improving agriculture and all the agriculture-related practices. So if we could reduce by means of space technologies, we could reduce the quantity of fertilizer, the quantity of water that we have to use. If we could understand the composition of the soil through satellites, and therefore we could understand better how to use the soil, how to change crop. There are a lot of things that you can do to reduce the emissions. Now, 25% is also quite high, and it cannot be enough but is one step in a certain direction. Or, for example, if you want to go towards renewable energies and renewable technology, energies and technologies, well, what you can do, for example, is to use satellites to find the best spots on the surface of the Earth where you could place remote power plants, for example, in particular photovoltaic ones. Because in this manner, you don't need even people that have to go there, because with satellites, you can control what is happening. And if you see that there is something wrong going on, well, then that's a moment in which you need to intervene. Otherwise, you monitor and you even manage from space. So these are just few examples, and I could continue, as I said, for hours, but I'm not doing that. To show that when we talk about space economy, that today is valued at around $470 billion and is expected to be a trillion economy by 2040. There are a lot of different numbers around that. In any case, it's a huge number. Whatever it is, the real let's say, number. Why I say that? Because $470 billion is the estimation made by the Space Foundation, which is quite a remarkable and credible organization in the United States. But the issue is that when you talk about space economy is defined by OECD as the combination of the space sector itself, and in that case it's easy because it's launchers, satellites, ground segment, payloads, so you know more or less how it is and what it is. But space economy is this, plus all the impacts, all the added value that you create using space for all the services that you can think of, from health to education, disaster management, for example, the use of space in remote situations, telesurgery, telemedicine, agriculture, you name them. So all this added value in terms of economic value, it cannot be measured because we don't have a global scale, not yet, a system to categorize the various elements that should allow us to give the real estimation, to provide the real estimation of the space economy. So when we say $470 billion US dollars is really underestimated because it's mainly the space part plus a very rough estimation of the impact of space economy. Which means also that space economy is really the backbone of the economies of the future because we cannot do anything without space. Today already and in the future even more. And which means that it's really a key element in all the discussions, in all the processes which policy and decision makers have to consider when they take, sorry for the words game, but when they take decisions, because in whatever governments want to do, they have to consider space. Now, at the same time, you know well that space is not so well perceived, at least it's not perceived as a key element from the general public. And so this book is also the, let's say, the goal, the ambition of trying to increase awareness. And that's the reason why we published it in Italian first, then now in English, and now we are working on a certain number of other languages to reach out as much individual as possible, as many individuals as possible in the world. So it will be in Chinese, it will be in Arabic, it will be in French, in Spanish, Portuguese, etc. That's it.
All right. Well, thank you very much for this interesting overview. Before going into some details of what I saw in your book, I had a chance to see the PDF. I have some of the more provocative questions and some of the more simple questions. I start with a provocative question for you.
Okay.
You have been working in international politics, so to say, being at the United Nations. You have mentioned a number of times now that decision makers will need data from space, should take that into account and so on. But many of the things that we measure from space in great detail, we kind of have known for some years, maybe even decades, where things are going. And in many places, politicians have not necessarily been influenced very much by data and by information, but by other considerations, let's say, vaguely. And just before, when we talked informally, you said you're no longer at the UN, so you can actually say what you really think.
Yeah. More or less.
And so, as we're academics, so to say, we can say what we really think. Why do you think, on one part of the question, that uh, this is the case? Why do we provide, we scientists, engineers, whatever, data are provided, knowledge is there, we know in many cases what the problems are, and yet action is slow or missing. And on the other hand, what do you think could be done with the information, or how to get it out there so maybe there is a drive, there is a need really to follow where the data lead?
Well, you know that I'm always positive, so I have to say that during my tenure at the UN, I've been witnessing quite a positive trend. When I joined the UN in 2014, at the Committee of the Peaceful Uses of Outer Space, we had 76 countries. When I left, there were 100, which means an increase of about 32%, which is not so bad considering that the committee was created in 58. So usually you have this type of trends when you have a recently created committee. So in the first years you have quite a huge increase because now countries want to join. In this case, it's been stable for a bit, just one country here and there adding its name to the list. But then in the last few years, it was this increase of 32%. And this is the result of there are several reasons. On one side, the awareness about the importance of space is increasing. But at the same time, we did create really a huge, for us was really important for us, the Office for Outer Space Affairs, to reach out delegations, in particular in New York, because also here in Vienna, you don't have all the member states present, right? And so creating this link with delegations in New York, increasing the number of member states here at the committee, convincing them that attending the meetings was important for them. And this was the first step, the first action we took. So 32% is not a bad result. At the same time, I got convinced also that if you want to increase the awareness at political level, you need to increase awareness in the public. And even if we do a lot, and you also, like me, we do a lot in terms of trying really not to present what we do and explain the importance, it's a huge task because it's sort of a step-by-step with small steps, but it works. So I'm quite positive again.
Do we have enough time?
I'm not sure, also because this was the negative side of the story. In reality, space is also becoming the new domain for conflicts or potential conflicts. And this is, in a way, not what I would like to see, but this is what is happening. This is not touched in the book. I'll write another one soon. They're asking me to do so, so I believe I'll do. I'll go ahead with that. And in reality, when you have a conflict on Earth, on our planet, this may become a space conflict. However, and again on the positive side, if we look at what is happening with the International Space Station today, International Space Station is this huge lab which has been built by 14 countries, Japan, the Russian Federation, 10 countries in Europe under the umbrella of the European Space Agency, Canada, and the United States of America. The first module was Zarya, 98, Russian Federation. And the Russians at that time decided to kill their own space station, so-called Mir, at that time was already in orbit since several years. They decided to send it back, so it was destroyed in re-entering the atmosphere to join the International Space Station. And on the space station, you have the Russian segment and the non-Russian segment. The non-Russian segment is where the other partners work together. And clearly the two big segments are connected, and they all work together. And on October the 5th last year, so I want to underline that the conflict in Ukraine started the 24th of February. So the 5th of October, there was a flight from American soil with Falcon 9 and Dragon, which is the capsule developed by Elon Musk, bringing astronauts to the space station. And there were 4 crew members, 2 Americans, 1 Japanese, and 1 Russian lady. And this didn't happen since 20 years. And now there is a rescue mission that we are expecting. Rescue mission that was, on the space station, you have currently 6 astronauts permanently there, Russian, American, and other nationalities. And these 2 capsules can bring back 3 astronauts each. So they're sort of a lifeboat for them. Because if something happened, they can go on board this Soyuz and come down, okay? Now, one of them had a leakage, so it cannot be used to bring astronauts back, which means that 3 astronauts were stranded on the space station. So there was a huge consultation between Russians and Americans, and they hosted a joint press conference end of January, where they declare that they decided jointly that the rescue mission will be under the responsibility of the Russian Federation. Now, why I'm saying this? Because I believe that space and the space station and similar programs can be a platform for peace, or at least for diplomacy. Because what I see missing is really diplomacy, if I may. Since now I can say that, I see diplomacy missing. And in space, we can do that still.
Okay, but the question about politicians not following advice that they have and have had for a while is not in the realm of diplomacy. And I know how things work with the UN and with other scientific missions where people are even high-level members of various countries from ministries and so on. But then those are the people who are under orders, so to say, and if they're not being told to do something by their government, it won't happen.
You mean in climate or in general?
Well, I mean, we can take climate, since you did mention climate a number of times, but also, I mean, I saw one example in the book where you say space satellites can help with detecting illegal fishing, for example. Well, but who is enforcing that? Who is doing anything about these things? There needs to be the political will to do so. And that's what I kind of, we're producing a lot of information, a lot of data, but people know what to do. They don't do it.
Well, there are 2 issues. The first one, and I can use some examples. So it's one example is that when I was at the UN, I was going around and visiting member states of the UN, not necessarily member states of the committee, to try to bring them to, to become members and to understand the importance of space, etc. And it happened that I had a meeting in New Zealand with a certain number of ambassadors from, all the Pacific Island states, which, by the way, are in a very bad situation because the sea level rise is bringing to extinction most of them, in a way, unless they move to New Zealand or to Australia. Okay, having said that, I made a presentation and I said, we have a certain number of space-based solutions. So tell us what you need and we will try to help you. And I said, well, we don't know what to tell you, because if we don't know what you can offer, we cannot understand if we have issues that you can potentially solve. So the first step, again, is to try to increase awareness. And so what we did a project with the government of New Zealand, paid by the government of New Zealand, to help on various topics that we had to find together. And so we did a mission, we went there, we discussed with people in the various governments, and illegal fishery was one of the main issues they had. And so we put together a project devoted to them to try to help the governments to use space in this field. So it's a bit, back and forth. You have to inform them, and then if you don't see that something happens, you have to insist, and there are various possibilities to do so. It's not always the case. In the case of climate change, the big issue is, in my opinion, now that I can speak a little bit more freely, is that, I'm joking, is that it's difficult to impose restrictions because this has an impact on the economy. And so you cannot create troubles to the country without having put in place some countermeasures. And very often you have governments which, in any case, last for a few years, and the impacts are spanning on a longer period. So on certain type of issues, the decisions should be independent from governments, or at least from the orientation, from political orientation. It should be more continuous, but it should.
That should, and we wish, yeah. The awareness that you talk about, that space is of importance to humankind in a way, of course, also goes for basic research.
Yeah.
And a lot of space exploration has gone on, be it manned space flight or be it spacecraft going to the moon, to Mars, to Jupiter, wherever. And as a planetary scientist myself, one of the rather, I would say, strange responses you sometimes get from the general public is, why do we spend so much money in space, and why do we want to send spacecraft to other planets and so on when there are still so many problems on Earth, and a spacecraft going to Mars costs $1 billion or something like that could feed so many people. Now, apart from the fact that saving $1 billion is not going to feed any more people because the money is not going to be redirected there anyway, and then we have the problem of other corruption, et cetera, et cetera. One of my responses to such people was usually, but think about it, we're not packing suitcases full of money and shooting it up into space. The money is entirely spent on the Earth for high-quality research, for engineers that build the spacecraft, for scientists that analyze the data. So you're actually investing in a high-quality sector of the economy, and very often worldwide. So I think this is yet another benefit that we have, and it doesn't only apply to satellites that look at Landsat or whatever, that look at the Earth back, Earth observation and monitoring things. It applies to everything that has to do with space, that it is supporting development of industry and of technology and of science at a level that hardly any other type of investment reaches. Is that something you've been thinking about too? Or?
Yeah, but this is also linked to what I said before, and the fact that the Sustainable Development Goals and everything you do is really linked to space. But on top of that, there's also stimulus for a high-level education, for STEM education, for gender equality or gender equality or empowerment. So SDG 4 is quality education, SDG 5 is gender empowerment, for example. And I have an example. One of the things that we did at the UN was, to create this program called Access to Space for All. And with the support of developed countries and spacefaring countries, in particular in this case was Japan and JAXA. JAXA is the space agency in Japan. Made an agreement with them, and they offered, and they still offer, by the way, flight opportunities for CubeSats. And in this case, were 1 unit CubeSat, which means 10 centimeters. So imagine a cube of 10 centimeters. And what we did was to make a call internationally for teams from developing countries. And the developing countries were established. There is an official list on the UN website. And so in this manner, we were able, for example, to allow Kenya to launch its first satellite back in 2018. And then Guatemala and Mauritius and a lot of others. Because the rule at the very beginning was that the country had to be at its first attempt of launching something in space. And Japan and JAXA were offering the launch campaign, the launch itself, the deployment of the satellite from the Kibo module. The Kibo module is the Japanese module on the International Space Station, and the first part of operations. So quite a lot of money from their perspective, in kind, whatever, but quite a lot of, let's say, effort. And what we had to do was to select the team and support the team in doing the first phases. What we did was also to oblige them, quote unquote, to register the satellite with the register of the objects launched into outer space, because it's a 3D, and it was something that they had to follow. But the added value was that the first satellite was built by a group of students from the University of Nairobi. And they made a proposal with the support of University La Sapienza in Rome, which is, by the way, quite well structured in terms of space activities since the Broglio time, so since the first satellite was launched. And they won the competition, they built the satellite. Now University La Sapienza and University of Nairobi have an agreement, so students from Nairobi are currently in Rome for a master. After that, they learned how to deal with space activities. They created the space agency. They approved the national space law. They registered the satellite. And now they are launching satellites quite often, 3-unit CubeSats, a little bit bigger. The team at the University of Nairobi is growing and growing, and this is helping the country to be present in certain international, let's say, situations, and is also increasing the innovation in the country. And these young students that can become important elements in the, in the country growing towards a sustainable, with a sustainable approach. So that's just an example, but I believe that, again, you have to link the SDGs and the need of increasing awareness of how space can really be a driver for innovation and for a better future.
Now, another topic that comes to mind when you talk about space and the importance for economy is the difference between space agencies paying for a lot of satellites, a lot of exploration that are government agencies or European Space Agency or something like that. And on the other hand, you have the private sector, entrepreneurs, investors, and whereas the government is more looking after the general good, maybe in many cases when it comes to these things, companies want to make money. So where do we kind of stand in terms not only of the benefit for humankind, but also in terms of open science, because a lot of the data that are produced today, there's a drive for open science, open data, that data are available publicly. But companies that launch satellites, they want to sell it to somebody. They want to make money. So how do you see a conflict there, or what's your opinion on this topic?
Well, it's a long discussion, but look, I'll try to summarize. Well, first of all, what is happening in space and is happening in a lot of other fields is that you have public money injected into the system to develop new technologies. When these technologies are mature, then usually the commercial companies jump into it. Telecommunication. At the very beginning was public money, technologies were developed, and then you have now all the main broadcasts and everything done on a commercial basis. You pay the service, you get what you want. If you want to watch your football preferred team, you can do that, or you can, the Olympics or whatever, right? But also for communication and sometimes also, also classified communication. The market is essential essentially in private hands. Then, at least the second round was Earth observation. So most of the activities at the very beginning, in particular, when you develop, new sensors, high resolution, were funded by space agencies. In Earth observation, we are still in the middle because there are a lot of activities still funded by governments, but also a lot of activities now on a private basis. Let's make the example of a company, just an American company, called Maxar Technologies. They develop big satellites on a private basis. They launch them on a private basis. They have contracts with the Department of Defense in the United States. So they serve the Department of Defense with these sensors quite high resolution. I know this technology quite well because, again, when I was there at the UN, we had an agreement and they were offering us images free of charge for humanitarian reasons. So in case of a disaster, I was getting, at the very beginning when we started the agreement, images at 50 centimeters resolution. This was what the US government was allowing them to do, 50 centimeters. Then we went down to 30. And then before I left, it was 15. So 15 centimeters for public, for civilian applications, free of charge to us because we had disasters to manage. But this means that the sensors have a far higher resolution for defense purposes. But this is done on a private basis, okay? So they sell the service. Still, as I said, in Earth observation, you have part of the missions funded by governments and part of the missions funded, let's say, on a private basis. And you have also constellations. For example, this constellation, this company called Planet, resolution is now so good, it's 3 meters. But you have a constellation, so you have a good coverage of the planet itself, and the company is called Planet. And they are selling quite well their images. Then you have access to low Earth orbit. So you had the International Space Station, which is fully public, okay, funded by governments through space agencies. And by the way, you have also the China Space Station, Tiangong, currently working. But now the technology is available. And so you have companies like SpaceX, good Elon Musk, developing Falcon 9, the Dragon capsule, able to go back and forth, apart today that they had to scrap the mission. Crew 6 couldn't go. And by the way, it was the first time that a commercial mission had a problem during the countdown in a crew mission. So it was the first time, another first. Okay, so they had to scrap today. By the way, with quite an interesting crew, because there is also Sultan Al Nayedi, who is the Emirati astronaut on board. So just to give you the feeling that it's more and more international. But okay, going back to the point, now low Earth orbit is becoming commercial. There are a certain number of private space stations under development or under study. One is under development because I saw the modules 3 or 4 weeks ago, really ready, quite ready. The company is called Axiom and is based in Houston, Texas. This space station, it's fully private, will be the first step, these modules will be attached to the current International Space Station. And when the Axiom station will be autonomous, it will be detached from the space station and it will stay in orbit, let's say, alone. Why I saw the module? Because through a B2B agreement, so a business-to-business agreement, Axiom gave a contract to Thales Alenia Space Italy in Turin to build the modules. And by the way, they are bigger than usual, 4.4 meters diameter. And so they are built currently in Turin. And as far as I understand, Axiom is also now ready to commit for other 2 modules. And again, they will be built in Italy. Just another example of the abilities we have. And again, it's B2B, so it's money coming from a private company in the United States, in Italy. Having said that, now public money is more going towards exploration of the moon, Mars, hopefully science, again, big science. Now the big science that we can remember, like the Cassini-Huygens mission or the Rosetta mission, or you name them. Really a lot of interesting mission, and JUICE ready to go, and others. Or the James Webb Space Telescope. Really extremely top-level scientific missions which will bring a lot of added value, a lot of innovation, a lot of, let's say, potential spin-offs. But, you know, as usual in space, it's not necessarily, it doesn't happen immediately. Now you have to wait a little bit. And one of the things that I'm doing right now is really to push a lot, and in the book also I mentioned that, space economy is strongly linked to basic research. And it's absolutely mandatory that we continue to spend money on basic research to be able to get new, let's say, innovative solutions for the future.
But coming back to one of the points earlier that I kind of thought about was, you mentioned that the Italians are helping the Kenyans to launch spacecraft and so on. If we have the transition of Earth observation to commercial operation, where they're selling a lot of images, and you basically have to rely on the goodwill of a company that give you some images for humanitarian reasons or so, isn't that a problem for a lot of what we would call the third world countries that can't afford to pay for these images and for the things that they need, one item, and the other one is, as I mentioned, open data, open science. You know, NASA, everything NASA produces is in the public domain, which you don't even need to ask them for copyright to reproduce an image, which is great, you know, but also the data are out there, you can get them. And if you go to commercialization of Earth observation, maybe a lot of important data get at the whim of companies, entrepreneurs that may change their mind. One day they say, yes, we'll support you, and one day they'll say, oh no, you have to pay for it now, and so on. So,
yeah, absolutely, but this is true not only in space, and also if you look at what's happening right now, for example, with the Starlink constellation developed by Elon Musk. Okay, if I remember well, he has 11,900 something satellites approved. So it's a constellation of 12,000 satellites. The idea is to bring internet everywhere in the world. Currently, I believe he has in orbit 3,700 satellites, and he is able to launch every day, sometimes even twice per day, Falcon 9 with, as a minimum, 50 Starlink satellites on each launch. So it continues to bring up satellites, and this will really, in principle, be able to bring internet everywhere. We have to remind ourselves that according to the UN, currently a little bit less than 35% of the population in the world is not connected. So now we used to be always connected, and if we are not connected for a few seconds, we get lost. But 35% of the current population in the world is not connected, and we just reached 8 billion human beings, I mean, in November. Now, the point is that he has he can switch on and switch off, and but he's not the only one, because Jeff Bezos is doing the same with a constellation called Kuiper. Is more or less half of Starlink, is 6,700 something. And then all the Chinese just recently announced 13,000 satellites, probably with more government approach. The issue is also, if I may, this is not mentioned in the book, but part of the second one, there is an issue from a political perspective, also because these people have the monopoly also of internet. So it's not only space, it's also internet. So whatever is related to communication in the world is in their hands. And what happened with Ukraine is that Elon Musk offered, I believe, 25,000 terminals. And for the first few months offered the service free of charge, which for him is a huge amount of money. And as you said, it's a commercial company, right? Now, instead of considering the revenues, you could consider only the costs. Still, it's a huge amount of money. And it's in the hands of someone, a private citizen, who decides to help or not a country. So I don't want to discuss more than because
his record is rather mercurial, so he changes his opinion quite frequently, it seems.
Yeah, but
I want to kind of latch on to something that you just pointed out, and I think that's a very important aspect of the space economy too. You said, what, 10,000 satellites here, 30,000 satellites there. It's getting fairly crowded up there. And we have a lot of satellites that fail quickly. And we have what I would call collateral damage in several ways. The two ways that I want to highlight here is one that kind of concerns a lot of astronomy friends, is that all these satellites destroy our night sky and destroy the possibility to do research because you constantly have some streaks of satellites going through your images. And also light pollution is a more and more important question. So that's a collateral damage that causes costs, doesn't contribute anything positive. And the second thing is that satellites can collide with each other, we know that. And in some cases it's done on purpose, in some cases it's done by accident. And then you have not only two bigger pieces, but a lot of small crap that can hit other satellites, that can hit the space station, that can cause a lot of damage. Now, what is done to regulate these things? And what is done, and who kind of owns a dead satellite? And are countries and companies being brought to task kind of to take care of their refuse up there?
Okay, so this is also quite a long story, but the point is that you have the space debris mitigation guidelines, which have been approved in 2007, and being guidelines are not binding. At the same time, the Committee on the Peaceful Uses of Outer Space approves everything by consensus, which means that each country is responsible of being committed to what they approved. In principle, should work. But this means that the process is very long, positive but long. After that, back in 2019, the committee approved the long-term sustainability guidelines, where you have also, among others, also a few guidelines related to space debris. The issue is quite complex, reason being that we need an entity, an institution, an organization like ICAO for aviation. So you have in aviation someone who, by the way, an agency, a specialized agency in the UN system, able to, I won't say manage, but coordinate the activities. And this is missing in space. And not only for debris, but as you mentioned, also for potential collisions. And on top of that, there is also a political issue, because if you have two satellites that are owned by two countries which don't have diplomatic relations, this may be quite a big issue. Because if you have a Starlink satellite and a NASA satellite, you know, there is an agreement between NASA and Elon Musk that every time there is a potential collision, he has the duty to make the collision avoidance maneuver to preserve the NASA satellite. But this is United States and United States. But if you have, I don't know, an Iranian satellite colliding, I don't know, with a US satellite, just to make an example, then someone has to enter into the loop and try to coordinate this maneuver. It's just an example to say that the sooner the better. We need an organism, an institution, a new entity, or an upgrade to the Office for Outer Space Affairs. In any case, something that is able to do the same job that ICAO is doing for aviation in space. It's a long process.
Indeed.
And in any case, it will take probably, it will be too long, this process, to manage potential issues that are around the corner. Because, you know, it's usually until you have a big event that is really creating, increasing awareness, all member states, they try to agree to disagree. That's wonderful, but it happens most of the times.
Indeed. Now, you started by saying how space exploration can help us getting some of our climate goals maybe under control, or at least know what to do. But that kind of brings me to another point that you mentioned in your book, that space tourism. And with that related, of course, is rocket launches and all these things are not necessarily known to be very environmentally friendly, let's say it that way. People are complaining about people flying somewhere with aircraft, you know. How does it look if people fly to space just for fun for 20 minutes or something like that, or half an hour, and have a greenhouse gas footprint that is enormous in such a case? What kind of conflict, or what do you see, where's this going?
Well, for sure, there are a lot of studies right now going on in a lot of countries, including Italy and Europe, to try to go towards, you know, green fuel and trying to reduce the impact of this continuous, I mean, this very highly frequent launches. More in general on tourism, you know, every time you start a new process, you have a lot of people against. It's normal. It happens with everything. What I see very positive in what they are doing in terms of, you know, going back and forth, only Jeff Bezos, because the others are, for the time being, on ground.
Well, Richard Branson too.
Yeah, Branson also is grounded for the time being.
Yeah.
And, you know, we will see. But because, you know, going to space is hard. Whatever you can say is still hard after so many decades. But I see the positive side of starting a new era. And the more the people go, the more they understand the importance, the more I hope we will have a sort of positive, say, injection of in the society. And on top of that, if we think about what happened at the very beginning of aviation, was exactly the same. I was giving a lecture to young students recently, and I started with New York Times, which a few years before considered Robert Goddard, which is one of the fathers of space, a sort of a crazy man, because he didn't know what he was talking about and how you can launch a rocket and things like that. And a few years later, they had to apologize in this piece of in this article, and it became, let's say, the most important apology that the New York Times did ever, because they were really bad against him. And then, after a few years, and they were ready to launch the Apollo 11, sorry. And so then the New York Times said, well, probably better I change mind, and I put, you know, and I explained that I was wrong. So the history is repeating itself, and when you see something that most of the people don't understand, well, they usually you hear a lot of criticism. I believe it's the beginning of a new era.
Well, you see a positive aspect. But
Always.
on the other hand, if you look what concerns some people these days, they don't look at new eras and what might be in 50 years. You know, there are people who chain themselves to airport perimeters because they want to protest the carbon footprint of normal aircraft. You know, and of course, and people are shamed into wanting to fly on vacation somewhere. So I don't see these people going very easy, and those are a lot of very opinionated people that are in the media a lot these days, view some fairly wealthy people too kindly who fly into space and create a huge footprint. So it's, you know,
Yeah.
we might have some conflict there in the future, I think. But
Well, one of the things that I mention in the book is that, you know, there is all this track towards using suborbital flights as a new way of transferring from one place on the Earth to another. And for example, when Starship, this new launcher or spaceship developed by Elon Musk will fly, in principle, he can fly from London to Los Angeles in half an hour. The only problem is that you have to go 100 kilometers, a little bit higher, and then go back. I mean,
and you
go
have
back
to
on
get to the airport, which takes a lot longer than...
Yeah, probably. But you see, apart the fact that you have to go to space, in 30 minutes you can go from London to Los Angeles, more or less 35, whatever. And it's something that brings 100 people. It's a beast, 100 and something meters tall, and is now going well through all the tests.
Yep.
So it will cost a huge amount of money, but the question that we have to ask ourselves, when the first, let's say, airplanes started to fly, we couldn't think about Ryanair, right? But now we can buy a ticket and go from one place to another with a very small amount of money.
But
It will be the
when
same.
the first airplanes flew, the world had a population of 1 billion. Now we're 8 billion.
Yeah.
So that makes a difference.
Yeah, it
right
makes
there.
a difference, but you know, it's more or less the same.
I want to ask one final question from my side before we kind of ask questions from the audience here. And that was another topic that is mentioned in your book, is the asteroids as a source for resources, so and maybe the moon as well. Do you see that as realistic in the near future, given the cost of getting there, establishing technology, bringing relatively small amounts back, because every kilo that you land back on Earth is difficult to get down? How do you see that in the near, far future? Realistic at all? Necessary at all? Or is that also the daydream of some companies?
Well, I believe it's going to happen. Now, how will be complicated, and when, I don't know. I don't know. I expect that it will take a bit of time. But as usual, you know, in this kind of endeavors, it depends on how much money you put into it, right? It's very often a question of how you want to focus on something, because then the technologies can be developed. One of the things that is never mentioned anywhere, and I just touched the point in the book, is that in any case, there are, and you know quite well, that there are some rules that you have to respect when you go on another celestial body. And these rules are classified by COSPAR. And if you have humans on another body, and then you bring the samples back on Earth, well, you have to be sure that you are not, first of all, you are not bringing terrestrial life on this body, and in return, that you are not bringing alien forms of life on Earth. So you need a facility somewhere. It could be in low Earth orbit, it could be on Earth, more than one. Well, we will see. The point is that it may become a topic for destabilization in certain areas from a geopolitical perspective. We will see.
Okay.
We will see. Probably not myself, but
Yeah, I think it'll take a while.
the youngest.
Yeah, but I mean, some people are thinking that you know, it's easy to get some resources, lithium or whatever, from any asteroid, and I kind of look at the how much it would cost to do that, and we still have plenty on Earth.
Absolutely, absolutely. But it will be fun.
Yeah, yeah. Anyway, I would say we have some time now to have some questions from the audience. I see there's a microphone going around, so...
I see some hands.
Okay, please, let's start here. And then I see in the back.
Thanks for a very interesting discussion. Question, are you optimistic or pessimistic about the use of outer space for weapons and fighting wars and things like lasers being developed and stuff? So are you optimistic or pessimistic, and why? Thanks.
Okay. I answer? Okay. Well, I'm optimistic by nature. As I said, I'm really convinced that diplomacy and space diplomacy can be helpful. Let's put it like that. I know that there are a few countries which are putting a lot of efforts in preparing themselves for, being more present in orbit for defense purposes. Let's put it like that.
Diplomatic. So, question back there.
My UN mind is still there.
So thank you very much for your very nice speech. So I have two questions. One is very easy. When I fly with a regular airplane, sometimes I cannot fly over some countries because there are airspaces which are controlled by countries. So when does outer space start? This is a very naive question, but I suppose that satellites just do go in circular orbits, so they don't care if they cross over the countries. Second thing is a question that was prompted by colleague Köberl, and that is related to the exploitation of space. So if I want to just make an example, if I want to put a resort or an umbrella on a beach in Kenya, then I have to pay something to the government in Nairobi. If I want to do that as a government, probably I don't pay because it's already my territory. But if I'm a private owner, if I'm a private company, I have to pay. So I'm wondering, are private companies paying something to the government in proportion, I don't know, to the quota of ownership that each country has on the earth or not? I suppose that if I'm Italy, I should get a little money if a private company flies into a space which is for a small quota is mine. Thanks.
Okay, so to the first question, I can answer with a joke, which is not a joke, but it's what happened to me when I joined the UN. So, I'm an astrophysicist by education, and I've been at the Italian Space Agency, at the European Space Agency, managing big programs, and never really focusing on the legal side of it. So I was really developing projects, right? And so, and I had a look at the agenda of the Committee on the Peaceful Uses of Outer Space. I joined at the end of March, and the committee is usually in June. So you start the preparation a few months in advance. So one of the first things I had to do was to check the agenda to sign and send it out. And so I saw an agenda item which was definition and delimitation of outer space. So I have to admit, I called my people at the UN, and I said, okay, now you explain me what it means. Now, it sounds like a joke, it's not. That agenda item is there since the very beginning, since 1959. And something that I learned at the UN and in general is that, at least in space, main countries, the main spacefaring countries, which means China, Russian Federation, United States, they agree not to agree. So they decided that they don't want to define when space starts. So there is, as per today, no official definition and delimitation of outer space. And the agenda item is still there and will be there for ages, okay? There are a lot of political reasons that we need, let's say, another environment to discuss, but all of them are in agreement not to decide, okay? The second question is again, will require a lot of elements to be provided, but in a nutshell, the responsibility is always of governments. So the private companies have to deal with their governments to get the license and to get the authorization and to get everything. Apart the frequencies that are allocated by ITU. However, in the 3D, in the outer space 3D, you have two concepts. The first one is non-appropriation, so the moon is not owned by anyone, any celestial body. All the celestial bodies are free because space is the province of mankind, or humankind, as I say, but the treaty says that the space is the province of mankind, which means that you cannot appropriate anything. And that's big issue, because the moment in which we will start a new era in moon exploration, and everyone wants to go to the South Pole, and you go there and you are Chinese and you want to stay exactly in the same place where the Americans are building their own building, or the other way around, well, there are no rules, because the moon 3D, which by the way was not so detailed on that, has not been approved by the main countries. No Russia, no China, no United States of America. So I am positive, usually. On the moon, a little bit less.
Another question? Okay, please.
Yes, good evening, and thank you so much for all the food for thought that you provided us this evening. I actually was, by coincidence, going to ask you something about the moon and about the use of resources and appropriations on our satellite, or not artificial in this case. You just said that there is very little regulation at present, but actually the Artemis program that launched its first flight only a few months ago, led by NASA, is actually aiming exactly at that, as ultimately at colonizing, actually, the moon. Do you think we are already in a new space race in order to set these kind of goals? And you also said before that some form of legal rules will probably take so long to be agreed that will be overcome by events. But this is actually something that could happen. I mean, the Artemis program is scheduled to continue already in the next few years. So what kind of outcome or solution do you foresee?
Okay, so first of all, the Artemis program is led by NASA, but is international, which is a difference with respect to what happened with the Apollo missions, because the Apollo missions were fully American. And the situation was partially different from a political perspective. Now, what happened and is happening is that currently we have 23 countries, including the United States of America, which signed the so-called Artemis Accords. And they are, it's a dedicated document with a set of principles strongly linked to the Outer Space Treaty and the other treaties. Italy was one of the first to sign. The last two, just to give you the feeling, were Rwanda and Nigeria. So Rwanda and Nigeria signed these Artemis Accords back in December. And it's a bottom-up approach. It's an attempt of having a common set of principles to be followed by the partners in this mission. However, Russia and China signed a similar agreement in parallel, not the same. And since everyone wants to go to the South Pole, and not only Artemis started already, because China has all the set of Chang'e missions. Chang'e 5 brought back quite a huge amount of samples 1.5 years ago, and they're already planning Chang'e 6 and Chang'e 7, and then human beings on the moon, at the South Pole. because first of all, it's quite a small area where you have a lot of, probably you have water, not probably, you have water, you have other elements, and it's in a position where it's not easily trackable from Earth. So everyone wants to go there, which means that you will have quite a crowded situation in the next few years with no rules at all.
If I may add to the question about the South Pole, it is water has been detected there, and so it would help having it there to just purify it and not having to get every bottle of water from the earth if you have a station
But you
there.
know that this is not only the only reason.
No,
The other reason is that from a you know, how can I say, it's good to be there if you want to check what's happening without being detected. I don't know if, again, I've been diplomatic enough.
Okay. Do we have any other questions? Anywhere? Do you see any? Okay, please. Yes. Okay, and then in the back. And then I think we probably will slowly wrap it up.
Okay, thank you so much for the explanation on the importance of space economy. Such interesting, and I see the contribution of this new realm of activities is mostly you have focused mostly on the contribution to the Sustainable Development Goals. I was wondering if there are other contribution that space economy could put in place to contribute to the overall planet economy. I'm referring in particular to energy and the capturing of solar energy outside the atmosphere, which is much bigger, 10, 11 times bigger per unit of surface than on the Earth. And what is the status of art of these new technologies? And do you see them possible in the foreseeable future? And what are the limitations or maybe even the risk associated to that? And then a second part of the contribution that I would like to know is that space economy would provide is, as any new activity, there are technologies which are developed specifically for space, but may be beneficial for other activities. Are there examples on this? Thank you.
Okay, so on space-based solar power plants, this is a very old idea, and you have periods where really there is a strong interest, and then other periods where no one is taking care of it. However, this is a moment in which there is quite let's say a bit of momentum, both in the United States, so NASA is really putting a lot of money, and not only NASA, also DARPA and defense-related, let's say, agencies. And also the European Space Agency, I believe that recently they launched this program called Solaris. It's not a huge amount of money, so it will allow only for some pre-feasibility studies, still is good, because the main problem is not to develop solar cells and put them in big systems in orbit. That's okay, easy. The real issue is to bring the energy down. So the other solution, and then the options that they are under development or under study right now, is to see if you can do activities in orbit where you have to use that energy and then to bring the product back, which will help in any case the situation on Earth. Now, the Chinese are also trying to develop such system. We at Bocconi are studying this activity as one of the main, let's say, forward-looking activities in terms of research. In particular, the economic model and how we can eventually propose ideas to the government to how to, use the money in the best way possible to try to develop such technologies. So the solution may be not to try to bring the energy back on Earth, because that's very, the most difficult part of the story, but eventually try to build plants in facilities in orbit where you can really develop products. So the so-called made in space. Let's see if it works. In any case, it will be not before 10 years from now. I don't see this happening before. Frankly, I mean, it's difficult to imagine something before. Even in the United States. China, you never know. Sometimes they surprise us. And the second question, Stefano, was? Yeah, it's linked to that, yeah. It's you have in the United States companies which are growing and growing and are really focusing on made in space. One is Redwire. It's now even, they went public and they are reaching 1,000 people. And they are trying to develop things in space, and they, for example, they're doing, I don't remember exactly the type of cable that is better done in space, but clearly costs a huge amount of money. So now they have to evaluate if really developing this cable is fiber optics in space is so much better that in reality it's worth doing it, right? So now this is just an example. Then you can, there are also some very funny things, like for example, there is the same company is invented a sort of a 3D printer to print pizza in orbit. Now, the first time I heard about that, I said, okay, why you have to print pizza in orbit? So for astronauts, it's fine, also because you have to print the first layer, then the second layer, then you cook pizza, and then you put tomato and the other stuff. So why you have to do it in space? Well, yes, because astronauts want pizza from time to time, and fine, you have always to be kind with astronauts because they spend so many months in orbit, confined, so okay. But then it seems that they are now discussing a contract with Disney for all the thematic parks, like, Disney World and things like that. So instead of going and buy a hamburger or a hot dog, you can have this kind of, drawers where you put a coin and this machine is able to print a pizza for you, real time. Now, why they have to print the pizza, I don't know, but it seems that there is a market there.
Well, one of the advantages of doing in space is you can put toppings on both sides, right?
Yeah. Well, this I don't know if they're doing it, but it may be interesting.
Anyway, in the interest of time, last question, please.
Yes, just to introduce, my name is Gianfranco Abuzzo. I'm from Napoli. I'm a little bit skeptical on the pizza printed.
Yeah, me too, also but, the taste. But
it looks very promising.
Let's see what happens.
Okay.
Always.
So basically, I wanted to also express a word of appreciation for this event, which is very interesting. And actually, my voice is a little bit biased because I had the pleasure and the honor to work with Ms. Pippo when she was serving the Office for Outer Space Affairs. And actually, I want to start with the memory that then could lead to my question. So I worked with the Committee for Peaceful Use of Outer Space in 2016. And actually, back in 2015, Israel was admitted to the committee. And of course, my first... Well. And yes, that's what I want to... and of course, my first day on the job, I was in charge of the seating arrangement and delegate from the space agents from Israel. He ended up sitting next to the one from Iran. So it was a very challenging day for me as being the first and not. So basically, this is an example, but, Ms. Pippo, you've mentioned that since day one, and you started leading that office
till you left the office, the trend of the membership of countries who joined the Committee for Peaceful Use of Outer Space increased like for 30+%. So behind this enlargement, right, there is a lot of negotiations, there is a lot of work, a lot of duty missions and talks with governments, and not only. So basically, this is my question. So could you tell us about the challenge that you went through in being behind this big enlargement, and even if there are some nice stories or memories in this phase that you were more like an advocate of space diplomacy than space economy? So this is my question. And I would also enjoy like some memories or some specific things that happened through your numerous travels, spreading the word of space affairs. Thank you.
Well, yeah, first of all, it's true that space diplomacy is another side of the medal. You cannot do space if you don't use diplomacy, because everything is in international cooperation. And science, I mean, most of the instruments are really done by teams distributed all over the world. When you have an astronaut of any nationality on the space station, you have control centers everywhere, from Japan through Russia down to the United States. So you have thousands and thousands of people from different cultures working for the same goal, which is the beauty of space. At least it works. But I believe there is a reason for that, and the reason is that when you are on the space station, the team, the crew, and each individual is dependent on the others. And when you are dependent on someone else, okay, the nationality of someone else doesn't count, because you have to work together if you want to survive. That's the real, I believe, the meaning of all of this. But we could discuss. Well, in December last year, I was invited by the UAE Space Agency to help with the Abu Dhabi space debate, which was opened by the Prime Minister of Israel. And so I went back to 2016, I believe, when for the first time I organized in Dubai, in agreement, with the support of the UAE government, which, by the way, joined the committee under my tenure, and it was the first space forum that then became the World Space Forum. So it was in Dubai, and the Israel Space Agency wanted to participate, and it was before the Abraham Accords. So the situation was different, let's put it like that. So it was difficult. How to bring the head of the Israel Space Agency to Dubai? So we had intense negotiations and discussions, and the proposal was made by the UAE government, so I have to say. So the guy moved to Amman, from Amman to Dubai, was always followed by the right people, so he couldn't move too much. He attended the meeting, and then he left. He was quiet, he never intervened, whatever, but it worked. Is in a way, was an attempt of doing the right thing, because, for the UN, you cannot co-host an event somewhere and at the same time you block certain countries, because you cannot do that. So my point was, let's find a solution, because otherwise I cannot come. If they want to come, they have the right to come. So we need to find a solution, and we found a solution. And then I was invited by the minister, by the way, the UAE, to attend the ceremony, the open ceremony, because they had in mind what happened a few years before, and so I was in the first row when the Prime Minister of Israel was opening the Abu Dhabi Space Debate. So I have plenty of these examples, but this is just one recent example that I believe testifies the importance of multilateralism.
Thank you very much. Now, I have a question for all of you, the audience. We've talked a lot about space. Who, given the chance, would want to fly, let's say, into Earth orbit? Who would get into a rocket? Hands up. Not that many. What about you?
No, I have an asteroid. I'm satisfied.
I want to go. But it has to be a return ticket, okay? Now, let's thank Simonetta for this really fascinating interaction, talks, opinions, analysis. Don't forget the book is available in the back if you want to buy it there. And let's give Simonetta a big hand of applause. Thank you.
Thank you. Thank you. Grazie. Okay?
Okay.